Hi everyone, this is one of our last few videos that we're going to be doing together. Today we are talking about patterning and linear equations, and this is really a review from what we did last year. So let's begin with this picture. If we think about what we did with growing patterns last year, what do you notice about this picture? Well, you might notice that there are some purple squares, one purple square that stays the same, and there are some light blue squares that change over time. So we can identify this as a growing pattern because we can see that for each term or each frame, the pattern is growing by 4 blue squares. We can also add some term numbers to the bottom of the pattern because it helps us to identify the sequence. And if we're describing the pattern, we could say in term 1, in term 2, and in term 3. So this is a great example of a growing pattern. When the pattern is growing, we could identify it by simply just adding in some numbers here. This one is growing by 4. So the purple seems to be staying the same. And from one term or frame to the next, we're adding 4 each time. That's called a multiplier. By the amount a pattern is growing is a multiplier. So in this example, the multiplier is 4. The constant is how much in the pattern never changes, even if we didn't have any frame. So for example, if you think of something like a term 0, what would that look like? Well, you could visualize it by thinking, well, what would that have to look like to get to the term 1? I would have to add 4 blue squares, so what I would have to start is just 1 purple square. So again, the purple square is representing the constant here, which would be +1. So those are our two components of a growing pattern when we're trying to take a visual pattern and represent it as an algebraic expression or equation. We can also represent a growing pattern in a table of values. So you can see the pattern up in the top right corner. So we could put these in as with the term on this side of a table of values and the number of blocks or squares on this side. And I think you'll remember that last year we had a whole bunch of different expressions and equations, and we used pattern blocks to make what the designs would look like on our desks. So this pattern, we see that in term 1, it has a total of 5 blocks. In term 2, it has 9 blocks. Term 3 is 13. And if we had a 4th frame or a 4th term, we would simply add 4 and we would have 17 blocks. So when I'm using a table of values, what I like to do is really identify on the side how it's growing, because sometimes I won't have that visual representation. So here I'm seeing, well, that's +4, this is +4, and this is +4, and it'll keep on going the same. That's what makes it a growing pattern. And these here, these +4s, remember, that's our multiplier. Now, we don't have our term 0 here, but we did have it on the previous slide. And we know that in term 0, we would just have that 1 purple square. And so I've added it into my table of values. You won't often see a question asking you for term 0, but I find it very helpful. So I like to add it in. So if we take this information now and turn it into a mathematical expression or an algebraic equation, we would end up with this. And hopefully this looks familiar when we talked about the number of blocks, like we did last year, is equal to the term number, so that's here, times 4, that's our multiplier over here, plus 1 that we started with. And if we shorten that up, we have this, 4t plus 1. Now, you know from algebra that t, we could make that s or x or z. We can make it anything. oftentimes you'll see it being x. Okay, so let's start with an example. Example 1a, create an expression and a table of values for the pattern, and b, identify what the 10th and 49th term would be. You could do either one first, but I always like to start with a table of values. So the first thing I'm going to do is label my table of values as term and output. And this could be blocks, but it's not always blocks. Sometimes it's squares, sometimes it's toothpicks, who knows what it is. So I'm just going to put output and term because they're pretty generic terminologies for what we're doing. My next step now is to label my diagram with my numbers, and I hope that you remember all of this. Now I don't have a term 0 in my picture, and I don't have a term 4, but I'm going to add them in there. So now I'm going to start filling in my chart. So I'm going to put term 0, 1, 2, 3, and 4. And how much is in each term. So I'm just going to skip 0 for now. I'm going to come back to that. I can see that in term 1 I have 5. Term 2 I have 7. In term 3 I have 9. And I don't have a picture of term 4, so I'm going to come back to that one. Okay, so first thing I'm going to do is try to figure out, well, what's my multiplier? So I can see that this one is going up by 2, and this also goes up by 2. So if I'm predicting what the fourth term would be, it's going to is equal to, I'm going to take this term number and I'm going to multiply it by 2. So 2 times the term number, and I need to add more to that. So I can see here, I always have this red bar. So if I think about term 0, if it's always plus 2 to go here, I'm going to add 2 there. If I think about term 0, I'm going to take away that 2. So it would actually just be those 3 red blocks. So 3. And I can double check that 3 plus 2 is 5. So my output will be 2 times the term number plus the 3 that I started with. So there's my algebraic expression or equation. Makes sense. Now, the second part of that question is identify what the 10th and 49th term will be. So I'm just going to put output equals 2t plus 3, and I'm going to move that out of the way. So I could, to answer B, I could extend my table of values, and I could write them all in up to the 10th term down here. And I know that I would add 2, add 2, add 2. But to get to 49, that would take a lot of work. So there's actually a much easier way to find the answer to this using our expression that we just determined. So what we could do is treat it like what we were doing in algebra. So if I want to know what the output is, I simply say, well, it's 2 times the term number plus 3 that I started with. So the output is 2, and let's do the 10th. So 2 times 10 plus the 3 that I started with. So output is 20 plus the 3, so the output would be 23. So the 10th term is 23. Now let's do the same thing for 49. So the output for the 49th term would be 2 times 49 plus the 3. So in my head, well, I know 2 times 50 is 100. I'm going to take one group of 2 off. So it's 98 plus 3. So that would be 101. So the 49th term is 101. Okay, so important that you can see that our multiplier here is what goes with our variable. What we started with, or term 0, is our constant over here in the expression. Okay, let's do another example. So this time we don't have a visual pattern. And as you move into high school, you're not going to see that anymore. So you can use a concrete representation, and that is fine. But what we're looking for now is just how would you solve a simple problem like this? You don't have to use a concrete picture. So what is the 101st term of a pattern that begins with 3 and adds 7 each time? Okay, so I don't have a visual, so I'm going to start with my table of values. So simply, here's term, and I'll use output again. Okay, so I'll leave term 0 there, 1, 2, 3, 4. So important that you understand here, when it says a pattern begins with 3, they do not mean term 0, they mean term 1. So it begins with 3 and adds 7 each time. So this is going to be 10, add 7, it'll be 17, add 7, and we are now at 24. Okay, so here I can start with my algebraic equation. So the output is going to be the term number times 7. So 7t. And now I need to think about what the constant is. Well, this is a little trickier because, in fact, if I think about what plus 7 equals 3, well, what do I know about this number? If 3 is less than 7, so that means I've started in the negatives. So it's actually -4. So here I'm going to put plus -4 as my constant. And we actually are going to change that to 7t minus 4. So that's our expression or our equation right there. Okay, so I use that plus 7 as the multiplier, and my constant, which was term 0, is -4. So hopefully you can see those two pieces of the equation. There's constant and the multiplier. Now the second part of this question is, what is the 101st term? So I'm simply going to find out, well, for term 101, it's going to be 7 times 101 minus 4. So we have 707 minus 4 is equal to 703. So the 101st term is 703. Okay? So what have we learned today? We can represent growing patterns this is a review of what we learned last year, in 3 different ways. So first we have a diagram or a concrete representation using blocks. We can represent it with an equation. So here I have the number of squares in this picture is equal to 2 times that term number. Here's my term numbers. And then I'm going to add 3 more. So you can see these 3 always stay the same. And I'm simply adding 2 each time. These 2, then these 2, then these 2. So that makes sense. Multipliers 2, constant is 3. Okay. We can also put a pattern in a table of values, and we know that it's important to have that 0 term in there so you know what the constant is. So again, in term 0, if I took these 2 blocks off, I know I would have 3. And then we see that nice multiplier here. Okay, if you have any questions, you can email me or post a note in the Teams notebook, and I will get back to you.